What is a wave function? Psi is the symbol of a wave function, and this psi represents the state of a particle at microscopic level, and it corresponds to the de Broglie wave of the particle. So this psi, called a wave function, depends on both position vector r and time t. Now question is, what does psi represent physically? To answer this question, please remember that a wave function contains all information about the particle and it describes the wave properties of the particle, but this wave function represents only the amplitude of the state, but it has no direct physical meaning. It means it is not measurable. To further interpret psi, in 1927, Bohr interpreted psi as square modulus called probability density. According to him, square modulus multiplied with d cube r is showing the probability of finding a particle at time t in volume d cube r between r and r plus dr. Hence, mathematically, it can be written like square modulus multiplied with d cube r, which is the volume of space where the particle should be, equals dp r of t, and this dp r of t showing the probability of finding the particle at time t in volume d cube r in some range. Hence, now if we integrate over entire space, and now if we integrate this equation on entire space and we are certain that the particle is somewhere in it, then the total probability of finding the particle somewhere in space must be equal to 1. Okay, so this is the physical requirement of finding the particle somewhere in space must be equal to 1. Here are few properties of psi. First, psi is finite and it can never be infinite. Second, psi is single valued. It means that for any value of x or t, psi must have only one value. And psi is continuous. It means no discontinuity in values of psi is allowed. Next, the derivative of psi should also be continuous. Hence, no discontinuity in the derivative of psi is allowed.